Okay, thanks everyone and good afternoon. I am Francesco Calabres and welcome to this last talk of the session. So today, together with Alessandro, we're going to introduce you our project related to the use of recommender system for personalized newsletter Watchfinder. But before starting that, a bit of context about our work. So first of all, for people who don't know Richemont, Richemont is a luxury holding company, Swiss one, that is the owner of many maisons and online retailers. You see here 26, the chart, and that essentially they are all related to luxury products from jewelry to watches, to pens, to leather product, to fashion and accessories. And essentially less than 1 year ago, Richemont decided to create what we call Group Data Office, which I belong to, with the goal essentially to leverage all the data that we acquire from all the different maisons or different stages in terms of product development, product distribution, but also interaction with the client, and use this information together with the AI in order to optimize the decision-making process, and so support the maisons become, from one side, more customer-centric, from the other side, of course, to improve the operational efficiencies or how we manage the process, and finally also to be more resilient. And to embark this journey for which we have started, essentially we have decided to partner with the Swiss Data Science Center, which is a joint venture between ETH and EPFL. That's why we started a collaboration with the team of which Alessandro is from, in order to help us accelerate the use of data science. In particular, today, we're talking about one specific project we've started, which one particular company, this is called Watchfinder, that is an online retailer of pre-owned watches. And here I leave the word to Alessandro, who will tell us a bit about the use case.
Perfect, thank you. Yes, so Watchfinder is primarily an online company. So that means you can go on their website and you can sell your watch, you can buy a secondhand watch, or you can subscribe to the newsletter. And today we're going to talk about these newsletters. So Watchfinder is sending out about 1 million newsletters every week. So yeah, definitely an important part of their marketing strategy. They kind of look like this one here on the left. So you always have a bit of content, but you also have like items that Watchfinder is trying to push. And these items, they are selected based on business rules, like, for example, what is particularly trendy at the moment. But the important point is that every subscriber is seeing the same content. So because of that, we thought this is really a nice opportunity for improving the way these newsletters work. And we can do that by providing personalized content to our different subscribers. So this is the goal of this project. And to give you a high-level overview of the project, so we start from click data. This is actually traffic data from the website. So every time a visitor connects, we have like a session ID, and we have all the items that were seen within this session. And with this click data, we want to train and to benchmark different recommender systems. And once we're happy with them, the idea is to take all the traffic from the websites that was generated by the subscribers and to use this to generate personalized recommendation for the different subscribers. Then with this recommendation, we will need to apply some business rules. For example, we will need to get rid of everything that is not in stock, and then automatically populate newsletters and send them out for our first A/B testing campaign. So this project is ongoing work. This month, we are about to start our A/B testing, but that basically means that today we will mainly be talking about how we train and how we validated the models. So speaking about the models here, in one picture, you see a bit of the whole story already. So let's start from here. So this is the metric of choice that we have used to benchmark different models. This is called hits at K. Basically, this means you take a session with all the items in this session, you take the last item out, and then you use the model to generate recommendation based on all the other items that were seen. And then we check whether our recommendations do include the last item that was left out. If it does, then this is a hit. So hits at K is a proportion. Here I had to leave out the numbers for confidentiality reasons, of course. And over here, you can see the models that we have been trying out for now. You certainly can recognize some of the usual suspects, like, for example, PageRank, the content-based models, MF, this is metrics factorization, item-to-item collaborative filters. These are some of the most popular ones that we see in the literature. You can also see a couple of popularity-based recommenders. Let's say these are these are based on the popularity of the different items. So we included them as sort of a baseline, and also because it resembles a little bit how the recommendations are done at the moment. And then finally, you see down here a couple of other models, word-to-back and a Markov model. This is also something that has been proposed many times in the literature, but if you want, it's a bit less conventional than the other approaches. And also in our use case, they are the one that seems to be performing the best. So today, because of time consideration and because these models are a bit less conventional and more performing, I will mainly discuss these two. So starting with the Markov model, the general idea in the Markov model is that every item is essentially a state of the Markov model. And so what we need to learn from the data is the probability of transitioning from one state to the other. So for each item, what is the probability of going into another item? And this is essentially the transition metrics of the Markov model, and recommendations are made by multiplying these transition metrics by the state vector, which is a vector that encodes all the items from the given session. So the reason why we like this model very much is, well, because it performs relatively well, but also because it provides us with a nice visual interpretation of how the model works. Essentially, this here is a network graph of the transition matrix. And this has been extremely useful in the past for communicating our findings to all the different stakeholders of the project. So when we talk to marketing, when we talk to the business levels, giving a high-level understanding of how the model works is always extremely useful. And the other model I wanted to mention is this word-to-back. So obviously word-to-back, something that we borrowed from the field of NLP. In NLP, one of the goals is normally to fill the blanks in a given sentence. Like, for example, Watchfinder sells blank watches. Like, if you have to fill the blanks, you can say Watchfinder sells beautiful watches, expensive watches, second-hand watches. So the general idea is that the same way that word-to-back recommends words to complete a sentence, we can recommend items to complete a portfolio, to complete a session. And again, this model performing well, but also providing us with nice visual interpretation. What you see over here this time is essentially the embeddings of the word. So word-to-back is learning a vector representation for all the different items. And if we reduce the dimensionality of this vector down to 2 dimensions, then we can visualize it in a nice chart. And here you can see we colored the different models based on the brands. So this image here is telling us that clients in Watchfinder, they tend to be very faithful to their brand. And again, it's something that the marketing levels, they could confirm. And also, yeah, they could understand what the model is doing and what the model is actually looking at. Okay, so far we have been looking at the objective metrics of this model. For the rest of the presentation, I want to mention a second type of metrics that we have been looking at. And if you want, this can be seen as a bit of an orthogonal metrics. And this is a subjective evaluation of the performances. So what does it mean? For example, it means that if we look at these recommendations, if we look at this as being like one of the set of items that were seen in a session, then the model is generating some recommendations, like over here. We can certainly use our hits of K metric to see how good these recommendations are. But the question is also, do we actually believe that these recommendations are good? Do we actually like this recommendation? And whether myself, I like it or not, that's not so relevant because I'm not particularly expert on these watches. But if we show these recommendations to our business experts, then it becomes very interesting to see what they have to say. They have been looking at these watches and at the watch market for many, many years, and they can tell you the whole story for every watch, and they can certainly tell you whether recommendations are meaningful or not so much. So what we did was to develop this sort of application that you see over here. And this is essentially showing a session, the items from a session, and it's showing two different sets of recommendations. And the whole task that we had for our business experts was to tell us which of these two sets of recommendations is more appropriate for this portfolio. This is a popular technique. It's called pairwise comparison. It's popular in the field of psychophysics. We liked it, especially because it's low workload. So you can imagine that business experts going through this, they simply have to say which of the two is better. It's certainly an easier task than, for example, give us a rating from 0 to 10, which is subject to many other type of biases. And so we essentially systematically collected preferences from our business experts in pairs. So our data set kind of looks like this one here, bottom left. And once we were done with our whole experimental design, the idea is to transform these preferences into a scale of quality, perceived quality. I'm not showing the mathematical steps for doing that. It's not particularly complex. And I have some references at the end, and I'm happy to share. But yeah, essentially, we are mapping our different models on a unidimensional scale of perceived quality, And the really, really interesting part here is that what we see based on our assessment of the business is kind of an anti-correlated trend with respect to our objective metrics. So you can see over here that the two models that seems to be performing best when we were looking at the validation on the historical data sets, they are less favored by our business experts. It doesn't change much for us. Simply, this means that the best way forward is to run an A/B testing campaign that is a bit more conservative, if you want. So we will not just focus on the models that were performing best on the objective metrics, but we will test against each other models that are either preferred by the objective metrics or that are preferred by the subjective metrics. But I realize I am leaving you with a kind of a cliffhanger. I hope in the future there will be other occasions for us to present the rest of the story. But so for now, just to wrap up what I just presented, we have developed a collection of interpretable and generalizable models. Interpretable because you saw that we were very interested in the visual description of how the model works. And generalizable in the sense that essentially we can apply these models to other brands in the group. You saw in the first slide that there are plenty. And also to other use cases as well, not just recommending for newsletters, but recommending in different contexts. We also validated results, both objectively, so based on the historical data, and subjectively. And this was very important for us, not just to understand the results, but also to keep our business experts in the loop, to keep them engaged, and to animate our community of data scientists and everyone around the topic of data science. And finally, yes, we're planning this A/B testing campaign, hopefully this month, with the idea of testing the best models, where best could mean either best according to objective or to subjective metrics. And if we will be happy with any of the models after our A/B testing campaign, then the idea is to start talking about the deployment. So thank you very much. We are very happy to connect And also, we're very happy to take any questions. I hope I did well with the time.
Very. Thank you. Thank you for keeping in time, and thanks for sharing with us your journey and your first experiments. What I missed a bit is how exactly is the personalized model, right, that is trained on the website data? How can that one be then ported to the newsletter environment? Are you sharing the same user IDs? So you can then basically show in the newsletter to the same user the recommendations based on her behavior on the website. Is that correct?
Correct. So essentially, we are able to link our newsletter subscribers with their activities on the website. So we're able to collect all the items that they have seen in the past, and based on all the data that we have from the web traffic, so not just from the subscribers, but from any visitor, we're able to make recommendations on which other items could be interesting for them.
Mm-hmm. Mm-hmm. Yeah, I think it's not surprising. I see it over and over again, and I also see it in the literature that sometimes you can get very conflicting results from the historical experiments versus maybe an objective baseline versus online experiments. For example, in news, we know that the popularity baseline is one of the hardest baselines to beat. So I was wondering, I don't think I've seen that. Did you also get to simulate some of these baselines, like the most popular or the heuristic that you know that's implemented in the newsletter? Mm-hmm. If you got to simulate that on the website data, and how does it fare against the classical models that you applied? Mm-hmm.
So essentially, yes, we did test this model here, which we call popularity. This is essentially recommending the top 3, top 5, top 10 most visited items on the website. Mm-hmm. And the other popularity that we implemented, this is already kind of personalized, because this is like the most popular item within the collection that the users have been looking at. And it's very interesting to see that as soon as you start implementing something like this, performances do go up quite a bit, right? So yes, indeed, like you said, a popularity kind of baseline is already a challenging baseline.
Mm-hmm. Mm-hmm. Yeah, we have a question also from Tim. Is there any intuition behind why Markov chains are working well? And why do you think the ordering of the visits is important?
An intuition on why it's working well. I mean, compared to other models like these brown ones or word2vec, I wouldn't say there is such a big difference. We have been also seeing like closer performances on other data sets. I would treat them as rather similar, right? We also tried some deep learning models that I haven't presented here, but yeah, all these models, they're based on interactions on the website, right? And these, okay, they tended to perform relatively close. If we have, for example, this model here, content-based, this is, if you want, a fundamentally different approach, because this one is looking at the features of the different items and it's computing an internal similarity, right? In this case, we do see quite a bit of a difference. I would tend to blame it on the quality of the items that we have. So they're not particularly granular. So the feature that we have to describe the different items, I think there is a lot that can improve over there. So this is my intuition behind why this is not performing particularly well.